Hello, I am Am. Today I am going to introduce our work, AffordMatcher, the Affordance learning in 3D scenes from visual signifiers. Affordance learning is a complex challenge where existing approaches primarily focus on the geometric structures, visual knowledge, and affordance labels of objects to determine interactable regions. Many challenges exist in localizing spatial affordance, while most affordance datasets primarily provide annotations for images and individual 3D objects, but often lack paired RGB images that capture affordance regions in those environments. Our solution aims to answer the question, how can we learn representations that diverse spatial affordances across different scenes from visual signifiers? First, we introduce our proposed AffordBridge, a large-scale dataset that annotates high-resolution point clouds and images for spatial affordance localization. The annotation flow includes three main stages. The first stage is scene processing. We downsample the point cloud while preserving the details. We also collect images and perform object view filtering by detecting candidate objects, ranking them by spatial location, scale, and contextual relevance. The second stage is visual signifier processing. We collect images, providing each image with bounding box annotations for human, object, and interaction region. The final stage is affordance annotation. Here we align image text embeddings using clip and retrieve the most relevant key view by maximizing cosine similarity. As presented here, our AffordBridge dataset contains around 300,000 high-resolution paired samples of 2D, 3D representations across 685 scenes. The interacted objects are annotated by 3D masks, yielding approximate 300,000 volumetric masks of interactable regions among object categories through various actionable affordances. This is the demonstration of our AffordBridge dataset. To handle the stated affordance matching problem with the designed dataset, we propose AffordMatcher, a cross-modal framework for zero-shot affordance segmentation in 3D scenes using visual interaction cues. The core idea is to align visual signifiers of human-object interactions with spatial affordance regions in 3D point clouds. Instead of directly predicting affordances from geometry alone, AffordMatcher reasons jointly over 2D interaction semantics and 3D scene structure to identify regions. Our architecture consists of a reasoning extractor that encodes interaction cues from visual signifiers and an affordance extractor that identifies candidate interaction regions within the 3D scene. These representations are aligned through a cross-modal reasoning pipeline that enables instance matching between modalities. Let's evaluate the effectiveness of our AffordMatcher on the AffordBridge dataset. As we can see, AffordMatcher achieves an overall MAP of 53.4, outperforming the second-best baseline by around 8, while providing superior localization of functionally relevant regions among both low and high intersection over union thresholds. The improvement demonstrates the effectiveness of visually guided reasoning in improving spatial affordance localization in 3D scenes. Now let's explore how the learned attention maps transfer reasoning cues across modalities. As we can see in the rest on pillow example, the visual signifier concentrates on the pillow region. Its spatial attention can emphasize the corresponding voxels on seating surfaces, confirming consistent cross-modal learning for affordance localization. Now let's move to the ablation study. The table below analyzes the performance of our AffordMatcher when inputs are changed or omitted. Results show that removing the 2D branch, only using raw point clouds, or fine-tuning on the object-centric PIAD dataset all lead to notable performance drops, indicating the necessity of the visual signifier in the AffordMatching task. Additionally, the TSNE visualization also shows that the reasoning module yields more compact and clearly separated clusters, indicating enhanced affordance discriminability. Finally, we move to the qualitative results. As we can see, AffordMatcher consistently produces compact, accurate affordance masks that capture both coarse and fine-grained interaction regions, such as knobs and prongs, while maintaining higher spatial precision. Other methods, instead, cannot handle the mentioned matching cases. Thank you for joining us today.